Okay, well, welcome to math modeling. My name is Radu Cascaval. I'm faculty in the math department, and I'm glad to see some of you that I know, and I'm anxious to learn, to meet everybody else. So, let's see. I'm going to start with a few things about the course, general things. And then hopefully quickly start talking about what math modeling is and how do we why do we learn it. I have a website that I'm going to post everything pertinent to the course. There's also going to be a lecture archive, so the video of the course, as well as the notes. So hopefully you're going to have everything in your hands and to succeed. I want to say a few words about the syllabus. So everybody got a copy. So there's going to be a required textbook. I want to make this clear. That is the third edition of Mearshart. In addition, I list, I think, two other or maybe three other books. Actually, two only. That I will use sort of during the semester to bring more examples or more problems. Now, they're not required in the sense that you can actually download them for free, chapter by chapter. And I don't know if you're familiar with this Springer website that you can download. You have to be on the campus network, but if you are, or if you're at home and you VPN, then I think you can access these. So the first one is called Mathematical Modeling, Case Studies and Projects. And again, if you don't see this recognized as, it means you're not on the campus network. Okay. So if you're in Honolulu in spring break, make sure, and you need a chapter of this book. Hopefully you won't, but make sure you can you get to the VPN. Okay. So what you do here is you can actually download individual chapters. So for instance, and one thing that I should say is that you shouldn't rush immediately and download everything, because I think this is here to stay for the semester. But regardless, you can go and kind of browse. We're going to start talking today about optimization problems, but these problems do not actually apply yet, so we're not going to use it. But I just wanted to show you. You can download these. And I don't know why this happens, but because my browser doesn't like this. Anyway, second time it works. I don't know why. But basically, you have the chapter in your hand, print it, keep it on your computer. If you print it, I recommend you think about the trees. So you print only like double-sided, 2 pages, or 4 pages probably too little, too small. Okay, so that's about these books that I list here. I kind of looked for. Well, I specifically look for books that won't cost you anything. But the funny thing is about this first one is actually, if you look through the format, I think it's like identical. The authors must have talked to each other with the book that we use, or what's more likely is these people used this book and then they came up with more examples. So anyway, so it will be almost identical. The second book is again, it's also free downloadable. You can also buy a copy. The nice thing about this second book is if you go here, some of these books on Springer Link, you can actually buy a print copy for $25, $24.95, including shipping and handling. Anyway, so that's for convenience. This is not an advertisement for Springer Link, but I think it's extremely useful. But you can print, again, chapter by chapter. Okay? And I should say the second one contains some things that we're going to be talking about. Maybe more graduate students will use some of the chapters. So we'll talk about this later. But anyway, so the important thing is we're going to use this, extensively. So make sure you have a copy. And this is not free, downloadable anywhere. If you find it, lucky you. Okay, so any questions about the textbook? No? Yes? Okay. Now, even on the front page, I kind of make this clear that we're going to be using computer software for solving this problem. So you probably know already. I mean, my preference is to use MATLAB. So I'm going to be using MATLAB. I don't expect that you guys have had exposure to MATLAB. So we'll talk about a little bit about what it does and how you can use it. But it won't be the focus of this course. It won't be to become experts in MATLAB. Okay. I'm going to show you basically the way we're going to use it is we're going to learn through examples. So I will post things on the website. So here's one. I already posted like a first example in the book. So I give you the code. What you need to learn is how to use it, how to modify it. Well, I mean, you have to learn what it does and how to modify it. Okay. Never seen MATLAB before. This might look strange. Okay. But that's how you make the computer do what you want it to do. So I'll talk about the format. Keep in mind, all it is a text file. It's a text, but it has an extension .m. Okay, and so anyway, so we'll learn how to run it, how to modify it, and get the output. I want to say from the beginning, so that once you write a code, or you use my code, or you use a code, a MATLAB code, you run it, you can actually write a report, or you can write the code in a way that it gives you a report. So a report is in HTML format, or it can, then you can PDF it or whatever. But that's sort of how I would expect the part of the homework to be turned in. Okay. And again, it will be really quick to explain these things. So I just wanted to show you. Okay. Now here I talk about basically what it is and why we use it. It is available for free in the computer labs. In fact, I think in all throughout campus now we have a site license, so it should be installed in the library when the new computers come, which should be convenient. You can also access it remotely. How many of you have heard of remote access to? Okay, so if you have not, there are some instructions here how to get access to MATLAB remotely. But again, if you're at a computer that has MATLAB installed, that's all you need. Well, for convenience, if you need it at home, you can purchase it, or on your laptops, you can purchase a student version. But for most part, you can do it remotely, or well, you can do it remotely, period, or you can do it in a lab. Okay, so I'm gonna make a plug for a course here that's kind of shameless advertisement. If you pass this around, so this is a syllabus for another course, which is not a required course, is not a prerequisite to this course, but it is a course that we offer. It's a 1 credit hour course, Math448Lecture01, and you probably got an email about this. So the only thing I want to say is got a quote from a student that took it last year together, at the same time as Math448, and that's what it is. So if I could read it, it says, "I found the MATLAB course invaluable in taking modeling. Last year, there were only a few of us from the modeling class that took the MATLAB course, and we became the go-to individuals in the modeling class for providing help to those that did not know MATLAB. Mathematical modeling is beep, and I would highly recommend it that if a student does not know MATLAB, they take Math448Lecture01. The fact that it's a challenging course, this is a personal opinion, so well, everything is a opinion of this particular student, and but there is sort of a truth to this, and I wanted to mention it here, is that if you have never seen MATLAB, or if maybe you've seen it but you'd really like something, thank you, more systematic, we offer this course, and it is shortly before this class. So anyway, end of advertisement. Regardless, I think the point that I want to make, sort of from the beginning, is this class may not be how you've done calculus, or if you've done ODEs, differential equations, or linear algebra, or whatnot, because it really requires that you use a computer. I mean, you cannot just sit with a pen and pencil and pen and paper and expect to do it. Okay, so if you're very proficient, maybe in a different language, you can and say, I'm totally against this software. Okay, maybe you can go by the first few assignments, but then it gets to a point where what I show you in MATLAB may not be easily doable in another language. Okay, and then it becomes kind of difficult to communicate with each other, and that's or maybe at some point you decide, oh, I can use 3 of them at the same time. That's fine. That's fine. But the point is, you want to make sure that you can communicate the outcome of your work to me, and I cannot use 5 different languages to explain the same concept. Okay. The book actually does somehow. If you read through the book, it has an example in Mathematica, an example in Maple, and then an example in whatnot, something derived, which I honestly don't know much about it. Okay, you will very soon. I mean, unless you're proficient in all of them, you'll soon realize that, okay, well, now what am I using to solve a problem? Okay. So please keep that in mind. If you have doubts, and feel free to come talk to me or about this aspect of the course. Okay. It's not like you sit somewhere and you take a derivative and set it equal to 0 and you get the answer. I mean, or use your graphing calculator for this. Okay. Now that being said, the choice that I made for MATLAB is because MATLAB is sort of the standard software or language in this field. Okay, it has evolved over the years. I mean, it was sort of started by mathematicians. Then the engineers picked it up and they developed it a lot. And in the past 10 years, it came back with a lot of capabilities that we need, as in mathematics. One of them being symbolic computations. Okay, so we'll talk about those. But MATLAB is primarily used for numerical computations, that is, with numbers, rather than with symbols. Okay, so that kind of distinguishes different computer algebra systems. Is it really powerful in the symbolic computation world? By symbolic, I mean, what's the derivative of x squared? Well, a symbolic software with symbolic capabilities would tell you is 2x, right? Numerically, it's, well, you tell me the point where you want to take the derivative, and I'll tell you the number, right? So it just takes a little bit of, I mean, it makes this distinction. And for most of what we need is numerical computations are essential. Certainly symbolic are useful too. So anyway, so that's sort of reason behind MATLAB. Don't just say anything else. So you have everything printed there. Oh, one thing on the home page here, I made a link to a MATLAB resource page, which lists a bunch of things you can explore. I mean, you can do everything nowadays. Pretty much, you can find lots of resources, free resources on the web. There are whole books. There are 2 books by actually the inventor of MATLAB that he made available online. Lots of codes. The best way to learn MATLAB is look at the code, see what it does, modify it. Okay. Use the help. So I'll show you in a second. Okay, so there are a bunch of tutorials. Maybe one that I found, again, the best way to learn is take the Math448. Okay, you'll hear me say this this first 2 weeks a lot. But short of that, there are lots of them. MathWorks, who's the company behind MATLAB, has a list of tons of tutorials, tons of video. I don't know how efficient they are. I mean, certainly, it depends on the personal taste, personal learning style. You can take advantage of one or the other. But the one I found kind of useful is almost like a cheat sheet. I must say that no single tutorial will actually cover what you need. Okay, that is to say, if you've done it, you invested the time, you spend an hour, 2, 3, go through what the tutorial says, and then yes, I know it, right? So every time you kind of run into a math problem and you need to use something, there's probably something you need to learn about the computer, a function or some. Okay, but just to give you this example, is it goes through sort of how to start, how to operate with MATLAB and other things. I will show you a little bit of this myself without a formal tutorial. But again, if you need, we actually have, even the UCCS website has a few tutorials down here. The web is full of tutorials. I wouldn't recommend that you go and start hunting for the one that works for you. I mean, to spend days and days and then get frustrated. There is a huge resource this semester. A MATLAB tutor, his name is Terry Spence. You might have known him, graduate student. He will be available 9 to 1 every day, actually. So if you need questions about MATLAB, and assuming he's available, he'll answer them to you. I was thinking to actually block a few hours of his time just to, so you have sort of priority, but it's up to you. I mean, you're the drivers. I would say see how it works. If you need, if he's extremely busy with other things, maybe we can block some of his time. But okay. So again, lots of resources. In the end of the day, at the end of the day, halfway in the course, I just tell you this from experience of other students, is if you feel like, oh my gosh, it takes me, 50 hours a week to just do things in this course, something's not right. Okay, we're not. As I said, I will give you the kind of the sample codes. I'll give you the, the codes that solve the problems we're talking about. Maybe in your homework you're going to have something change, something slightly different. You can, you should be able to just modify it and do it and report and go forward. Okay. The goal here is not to learn everything in MATLAB. Okay. And again, I'm repeating myself, but the goal is to solve math problems and math modeling problems and use it at some stage in that process. Use MATLAB in that process. Okay. Did I miss anything? I will post the homework here. So the first homework, I say it's due. It's going to be due a week from today. So that means we have to start talking about something fairly soon in chapter 1. So, and I mentioned the exams. So there's going to be a midterm and a final. So that's and the graduate students, I think, will have some sort of project on top of that. So I think it's all in the syllabus. The lectures are going to be available on the website here. If you're not familiar with this, first time you visit the lecture page, you might be asked to do something, but well, okay, we know who to blame this, right? Anyway, you're probably familiar about the video archive page, and it should be also on iTunes. So, anybody knows iTunes? If you
Can we actually put the lessons on our iPad?
yeah,
Cool.
you can play with me. Just no, but the point is that you can subscribe to the feed, sort of, so you get. It downloads automatically on the computer. It's not perfect, but anyway. All right, so finally, so here you just register if you've never done it before. Otherwise, just sign in with your name and email address. Okay? All right, I'm really done, I think. Any questions? Yes, no, none. I have a tentative schedule here. It's kind of on the conservative side, but meaning that we hopefully will be ahead of it, but if not, hopefully we won't be too much behind it. But the important thing is to almost forget about that print copy of the syllabus and always refer to the website. Okay? So during this semester. Okay. All right. So let's. No questions?
Can we go in the computer in class if we have that on it?
Sure. Yeah, it's as long as you don't do other things with it, that's fine. Yeah. Any other questions? Yeah. Yeah, okay. I said it's not perfect. It's going to happen in a week or two, yeah.
So if we do go faster than this, would you move the midterm, or is that set with that?
Yeah, actually I had it before spring break, but then it's kind of set. There might be a in-class and a take-home portion, so I'm saying, the in-class should be set, okay? And so don't plan on not coming back from spring break. Okay. Anything else? Yeah.
Considering this is undergraduate and graduate level, what's the difference in work like homework, projects, tests?
Homework is the same. So there's going to be a project that the grad students will have to do. And I did not, I talked about it in the syllabus. I haven't given the details yet. I will talk about this in the next 2 weeks. Okay, yeah.
If we go ahead and do the project, will we get credit for the graduate level class?
Oh, I don't think so. I think you have to be enrolled in.
Okay.
Yeah. But yeah, you're welcome to. So again, this is okay. So let me start talking about a little bit about the nature of this course, and then one thing that's nice about modeling is that it appeals to lots and lots of fields. I mean, it is sort of what math can do in all the science and all the fields, right? So probably some of you are not necessarily math majors, and everywhere you go, you see, oh, I want a math model, right? So so you can be very powerful, not at the end of the course, but if you have an expertise in modeling, you can have a career in it, right? Now, a course is not going to give you the full expertise, right? In fact, it's going to actually just prepare you or expose you to what it takes when you are in an environment where math modeling is required to actually do something, okay? So even though here we're working on baby models, in examples, textbook examples, right? That's how they say it, right? We're not solving a problem that the company in Woodland Park would like us to solve, right? Or some very extremely concrete problem that if you solve it, whether you solve it or not depends on the existence of that company, right? So we're going to learn about aspects of what it takes to set up a model, what it takes to validate a model, what it takes to solve it, and actually what's extremely important is what it takes to communicate what you've done in the model with the people that have no clue about mathematics. Okay? So those are sort of the main goals. The examples we're going to cover, I mean, are by no means exhaustive. So these other two kind of resources that I gave, these two other books, just complement, add to those list of examples. But even those are not going to be comprehensive. So if you have an interest in some whatever, right? It would be actually nice, certainly come talk to me. See if we have the tools, okay? If we'll ever learn the tools for that particular situation. We may not, right? So one other thing that I should say, like in both the books that I mentioned, not the required one, there are a lot of models that require partial differential equations, and many of you have not taken those courses. So, but that certainly opens up huge kind of pool of problems that you can model. Okay, so the more math you know, the sort of the broader the coverage of your expertise can be in terms of math modeling. Okay, so I'm not saying anything fancy here. I'm just pointing, sort of, if you have an interest in a certain direction or a certain, maybe you work in some company or maybe you will work in some company, I'd like to hear about it. Okay, and I'll be happy to, look at other references, other things. You might be doing a project, even if you're not grad students. And all I want is that you have a rewarding experience. At the end of the day, is you finish this course not because you had to take it, but because you really fit your interests. Okay. So there are three main kind of motives that we're going to be touching in this course. So sorry for my handwriting, but it's going to get better hopefully. So the first kind of big pool of problems are going to be labeled optimization problems, because they're in practice you end up with many questions that where you want to optimize something. You want to maximize some profit, you want to minimize some cost. There are things going on in different fields. In all the fields, you can actually set up a problem where you can set it up so it's an optimization problem. So we'll start with those, and that's going to lead us to a lot of the applications. Then we're going to talk about dynamical systems, models, problems, and as a subset sort of those, we're going to be talking about control problems. And sort of the last one, sorry for the, it's actually here. The last kind of class would be probability models. Now, if we had all the time in the world, then we would really go into details in all of them. I will probably talk spend least amount of time on the probability models, simply because you can spend a whole course on those. There's of course, we offer another course, stochastic modeling, that really discusses those. But we'll talk about some of these. Okay, so. And by the way, I should say, I like when the class is very quiet. But if you really have if you have any questions, just don't be shy. Just interrupt and ask, because I mean, then that's pretty much how you learn. I mean, being active, not just passively listening to somebody talk about. Would be ideal if you all had computers, or if we were in a computer lab, but that is not the main. As I said, that's not everything that we'll do. So there will be some paper and pencil part in each of the problems. So let me talk about optimization a little bit. Start talking about what is optimization. Well, in one dimensions, so what do I mean by one dimensions? Basically, I mean that I'm looking at a function, some variable that depends on another variable, right? Just one variable, real numbers, x, and I have a function that depends on that x. And what I want to maximize that, right? I want to find the maximum. So this is y equals f of x. Okay. Then you graph it and you look at it and say, oh, I see the maximum. That's the maximum, right? Well, sort of. In practice, what do you typically what you do is you have, you don't just have a function. I mean, that's not the starting point, right? The first part of the problem is find the function that, has an expression that you can deal with, right? Well, graphing may not be too difficult once you have that function, right? But graphing is not the end of it, because you may have a maximum that you don't really see on a graph, right? It could be, the scale could be so huge that you may not see a maximum, or you may see lots of maxima and so forth. So, of course, theoretically on paper, what do? Take the derivative, and the first thing is see the critical points, right? So you set the derivative equal to 0, and then hopefully then you can decide, is it maximum, is it minimum, is it inflection, is it neither, or so forth, right? So that's calculus 1. But in reality, problems coming from, or functions coming from models, from mathematical models of a realistic problem, is taking the derivative may be impossible, right? Let's say you're lucky that you have a function that you can just write down very symbolically. Then, okay, maybe you can take the derivative. The next hurdle is finding the solution of f prime equals 0, right? That's not always possible to explicit it, right? So you really need a computer for every single step of this, and you have to deal with these situations where you may not get an exact answer for each, right? So you probably now, that even if you have some some function like this, I don't know if this is a maximum or not, but I don't know, let me put a minus here or something. Then the derivative So this is in the case where you have the function, you can take the derivative by hand, but now you are facing the task of setting this equal to 0, right? And what do? You need a calculator, right? Okay, so you can do this with a graphing calculator. No big deal. But because of the sort of the nature of the things, it's probably better now to use one of these computer algebra systems. So I will show you very, very briefly how to solve this in MATLAB. And then we're going to move to a baby problem that actually you have to start from the very beginning to even say what x is, what is f, and so forth, right? So set up a model. So we're going to set up a model. Let me just open MATLAB, since I've talked so much about it. Show you really quick how to use this, to solve this. Now I do have it locally on my machine, but if I don't have it on my local machine, I can remote desktop to what's called RATS, rats.eas.uccs.edu, and use your UFP. Credentials, and what you do is you just go on this remote machine that you have access to lots of software, not just MATLAB, lots of software. Okay. I don't know how long it's going to take, but anyway, so I have access to I get MATLAB, and I've never seen it before. And what you're probably going to see in first time you open it is kind of cluttered, have all this kind of stuff, right? So for the most part, I'm not going to be using the folder. I'm not going to be using the command history. Let me leave this what's called a workspace. So I have these two windows which I can play with. I have some garbage there. I'm just going to clear it. CLC clears it. Okay, so this is how you start fresh. Okay? So I simply want to solve that optimization problem, right? Okay, so how do I do? Well, many ways you can do it. But the one way I want to start with is do it symbolically. Okay, remember that's not the strength of MATLAB. Okay, but it's convenient that it has this capability. And by the way, if those of you that have used RATS before to connect remotely, now even remotely you can do symbolic computations. In the past you were not able to do it because of, I don't know, 64-bit compatibility and so forth. But anyway, so right now everything that I show you, you can do it remotely as well. Okay, so the first thing that I do is, and this is kind of unusual for MATLAB, to have to define that I'm going to work with X, okay? But again, we're living in this symbolic, we're working with the symbolic objects. So, I mean, that's the price we pay. We just have to define. We have to say we're going to work with X, okay? All right. The next thing is I'm going to define the function, okay? And you can see it. I mean, it's obvious, right? The way you define is just equal. Okay, it's not like other software. It's just simply equal. Okay. Now, this is a command window, and MATLAB is just waiting for your next command. Okay. Yeah.
Do you want 2x to
Is that what it was? X squared is the derivative. Yeah. Right, so when I take the derivative, it's going to be 2x. Let's see. Okay. All right, now, let me clear this. I'm going to start fresh again. I mean, I'm not really starting fresh. If you look in the workspace, you can see those two objects are already defined there, right? So X and F, and they're one. There's also the well, they're symbolic, right? So that's what it says. It's symbolic, and it's a one-by-one. So the big thing you have to know about MATLAB is MATLAB thinks of everything that it works with as a matrix. So if it's just a one thing, it's I mean, if it's just a one scalar or not one number or one object, well, object is wrong. It's just a one-by-one, right? So number 3 would be thought as a matrix, but a one-by-one matrix, right? So here it's a one-by-one symbolic. So you can see you can make a 2-by-2 matrix with each entry a symbolic variable. Okay, but anyway, so I've defined X. I didn't have to do it again, but I'm just showing. And the next thing I'm doing is semicolon, meaning it goes through that command, but it doesn't display something out, as a result. Okay, just to keep it kind of short. Okay, so that's F. What's the next thing to do? You can differentiate, and there's going to be commands that you probably don't know if you haven't worked with MATLAB. And the best way to do it is, well, I want to say most of all the commands, well, all the commands, I want to say all, but probably is not true. All the commands that you will ever need in this course, you will have seen prior to you having to work on the problem. But if you ever kind of need something, you can always go to help. In fact, this fx here has a list of all the functions categorized, so you can, I don't know, probably mathematics. Actually, yeah, you can go mathematics, or you can go to, one thing I should say here is one peculiar feature of MATLAB is it has a core set of functions, and then it has functions that are very specialized for, let's say, control systems or image processing, right? So each of these has very specialized set of functions. Now, the one where you have symbolic capability is called Symbolic Math Toolbox. So if you don't have this listed, you cannot do symbolic computations, and you would get an error when you type SYMS. Okay?
So we should be able to get to all those through RATs?
Yes, now.
Okay.
Which is a big.
Yeah.
Okay. So anyway, I don't want to go through much of this. I just want to show you, how it works, and so you can find things like that there. It does display the answer, right? Symbolically, right? And if you ask me how it did, I don't know. That's just magic, right? Just took a Calc 1. This computer took a Calc 1 class. Remember, you recall, right? When you learn about derivatives, you just know the rules, right? So I imagine these rules were kind of embedded in this. But anyway, but notice that I have a new variable called ANS, which I didn't call it that way, right? So one thing that you can always do just to make sure that you keep track of what you've computed is just to call it somehow, right? So I call it dfdx, but you can call it whatever, right? You can give it a name, right? You can fx, or I don't know, let's call it fx. Okay? So now it has created the fx, and it kept it there, right? And it's this function. It's still symbolic. Well, okay. So we were wondering, how do you? I keep deleting so you don't have to scroll. I guess you can do it. You can see on the bottom there too. But anyway, everything's still there, right? I just cleared the screen here, but so let me plot this function. Easy plot fx. Okay, so I'm just showing you the real basics. basic commands. Sorry if you're familiar with this. But, all right, so now you see it. Okay? But it's hard, right? It's hard to say if you have a minimum or a maximum, right? Well, it's not hard to see. I mean, in this, by the way, why negative 6 to 6? Well, EasyPlot uses negative 2 pi to 2 pi as by default. So it's 6.28, right? But you don't really want that. Now, here's one thing that's going to happen. You see this window here that pop up here? Now if I want to go and do something else, the window disappears. Okay. It's kind of frustrating. Okay? Don't spend hours to find that. Okay? Just listen to me here. To find that figure. Right? So, where did it go? Well, it didn't go anywhere. It's just somewhere here. Okay, and this is Windows 7, which is a great thing. That I can find it, right? But I didn't have to wait for Windows 7 to show up to find this figure. What I can do is I can actually what we call dock, right? So I can dock this. So I still have everything on full screen, and I just want to keep it, right? So I've docked it. Dock is this thing here. Okay, I want every single window to be on the same screen. Okay, so hopefully everything is going to stay there. And now, let's say our x is only positive, 0 to, I don't know, you see 6 is kind of big, right? Let's do 4. Now, if you put, instead of square parentheses, if you put just parentheses, I think it's going to give an error. So there's going to be stuff that you're going to be frustrated initially. Okay? What do I do, Don't spend too much time on this. Just kind of look at the help or whatever, right? Gosh, so hard to see. Do I have a minimum? Well, I have to go. Well, I can see that between 0 and 1, if there is a minimum, that's going to be the minimum, right? Hey, and there's the minimum, right? I have to say I'm very lucky because I just picked that at random. But okay, so it's a big issue here. How do you get to the thing that you want to conclude, right? Well, plotting has a lot of limitations, okay? Because you don't know what the window size should be and so forth, okay? And this is an easy example. We're doing the Calc 1 stuff, okay? So we have not a maximum, but a minimum. Okay, so, well.
Are we dealing with the derivative of that? Are we more interested where max is 0?
Oh, thank you so much. We're dealing with the derivative. I'm not plotting, I'm plotting the derivative. Thanks. Maybe I should have looked at, well, okay. So I'm not so lucky then. Let's go back. Okay. All right. So what should I do? Now let me go back to 0, 1 here, right? Well, so I'm not looking at a maximum, thank you. But I'm looking at what? Zeros of this function. All right. Okay, so the 0 of this function doesn't look like it's in this interval, right? Doesn't look, but it looks like there is somewhere. That's the other thing. You should keep things into perspective, right? Don't change the problem. I've changed the problem, right? I was looking at other things, right? I'm looking at the maximum or minimum of the function. So I'm looking at zeros as the derivative. Okay, so, well, being a cubic function, I know there is a 0, right? Okay, so that wasn't random, but where the 0 is still not very clear, right? So I have to ask the computer how to. Okay, so I have to solve fx equals 0. And what do you know about cubic functions? They're difficult to solve. It's not impossible, but you're going to get cubic roots, all kinds of stuff. There are some formulas, but you don't even want to know. I see some complex numbers here. So, in fact, it's a big mess. In fact, you look at the answer where I didn't call it anything. You see it's 3 by 1, so I have 3 solutions, right? It found all 3 solutions, but are not all real, right? So it found 1 and 2 complex. Where are those complex roots? On the graph, there's only one x-intersect, right? Of f prime with the x-axis, right? See, it's not easy. Well, okay, but first of all, let me give it a name here. X crit. I don't know, x. This is believe it or not, this becomes challenging. How should you call something? X critical, whatever. Okay. All right. Well, now at least I don't have that A and S, but I have this. It's too long. I should have called something shorter. But anyway. Now here's where MATLAB comes into comes in handy, is you can actually, of course, see the same, but in a better way, right? Not symbolically. This is almost like it's a symbolic. You could almost see the square roots or something, right? I think you can. Well, you don't see them here, but you can. Well, okay. I just want to see the solutions. So I use this double command, double, and it converts. You see the answer now. It's something you can visualize, right? Almost -1, but not quite. This double command. Does anybody know what it does? Yeah, but not just that. Right, double precision. But the one thing that everybody has to understand is we were doing our computation in the symbolic world, right? Double brings it into the numerical world, okay? It's a big, okay, so now it's a huge change, okay? It may not show like this, but it is, now it's a number that MATLAB is really happy to work with. Okay, these numbers, complex numbers, are MATLAB is very comfortable with. Okay, all right. So, what else should I say? Of course, I didn't give any name to this, so I should call it somehow, right? I don't know. You can even call it the same thing, as long as you didn't. Right? You can call it, if I use this name, right? I made a conversion, but it just changed that nature of the, yeah. Right. So yeah. So that's a computer science question, and I only know a little, but I know that the variables that are stored, so the things that are in this workspace, have some memory allocated, right? And as long as the size of that variable doesn't increase, it just uses the same memory allocation. Sometimes what will happen is that we will increase the size of, we could call the same variable but increase its size. Then it becomes, there are some flags that show up. They say it's not very optimal. Anyway, so optimizing the memory usage and so forth is an interesting thing. But not really mathematical. Okay, so final thing. Remember I told you that MATLAB has this, everything MATLAB deals with is a matrix. Okay? So this thing now is a matrix. It's a 3x1 matrix, right? But you don't care about those last two ones, right? So you can just extract only the one you need. So that's, let me change the name. And you extract it by saying, by putting this in parentheses, is a one, the first entry in that matrix, right? Well, the matrix is 3x1, so it's clear what the first entry is that, right? If it were a 2x2 matrix, you would better say it's a first row, first column, right? But here it doesn't make any difference, right? So you've, and give it a different name. Of course you could, doesn't matter. Names is something, you have lots of choices, right? So you can, if this is a little bit confusing to you, always give it a new name, okay? All right? Anyway, so that's the answer. Well, okay, that's the max or minimum. We still don't know if it's a max or minimum, right? The derivative was negative and then positive, so the function was decreasing and then increasing, so it is a minimum for the function f. And you can see it if you plot f, not fx, and you minus 1, 1, let's say. So it's right here, right? Right on here. Right? Okay. All right, so thanks again for pointing that out. I mean, it is important, right? And if you do this in your homework, I'll say, don't do it. So don't. I'll say it now. Don't. Every time you have to keep things in perspective. The one thing that the modeling helps is actually when you get to the end of your computation, of your model, of your solving the model, of your using the computer to solve the model. You have to translate everything into words and say, again, tell your brother or sister, mother or father, somebody that has, scared of math, say what you've found, okay? And that's a check that helps you catch, hopefully, most of this, possible errors that are done in the process. Okay? Let's. Well, let me say two more things before I close this. Is this way of doing business with MATLAB is not efficient because it is a sequential. It asks for a command at a time, right? And yes, you can go back and recall a command, but that's not very efficient. Most efficient is to use what's called a script. Okay? And notice that I've opened what's called an editor. And in this editor, you can actually, and now it's gone, right? Where'd it go? Windows 7 is good. I found it, so now before I lose it again, I'm going to dock it. Now, it went above the figure. I don't really like that. I want that to be like a window here, right? And you can play with this. Okay, and if let's say I want to redo everything that I've done, but now in one stroke. So what I do is I go to the command window history just because I'm lazy to rewrite everything. Wait. Okay. I think I needed to do something else. to record this as a diary. But since I haven't done it, let me just say the following: that you can. Oh, that's another thing. You can click this little thing here. So this is not undocking. Well, this is undocking, right? This just takes it as a separate window, which you may lose again. So instead of undocking, you can maximize the error. So it just kind of goes on top of everything else, but it's not undocked, right? You can put it back in and find the other. Okay, so I just want to focus on this for now. So what did I say? F was x4 minus x squared plus x. Fx was the derivative of f. By the way, derivative you don't have in this case to say is with respect to x, but some other times will be useful. And the last thing is solve xc solve f. No, x, right? Fx, right? Remember? Yeah.
Can you like embed solve fx so that you can just cut the command, just start like xc equals the numerical version of solve fx?
You know, you may be able to in the newer versions. I don't know the answer. The point is, we're not really doing the most efficient coding. Okay. We just want to do some coding that gives us the answer. Then we can. That's a separate process, right? Optimizing the code itself, right? But I don't know. It's possible. A lot of the things that I do are either redundant or really slow or something, right? But we're not looking at speed at this point. Okay. So remember we did this. What was the last thing we did? And the one thing that we didn't do is evaluate f at this value, right? And this is going to be f min. Well, it's of course the minimum in whatever interval it is, right? So now you have this nothing but what's called a text file that you just wrote, right? I wrote it fairly quick. How did I know to write all of this? Well, I've kind of went one step and I saw what it does, right? So if you, right? If the first time you write it, you're not going to know how to do this. So what you going to do? Well, I'll tell you. Huh? Practice. I mean, experiment. Okay. So let me just do this. Well, you can run this thing. If it wasn't saved, it will ask you to save. So let's save it as the first one. It has to be .m to be recognized. Oh, already exists. I don't care. Okay. So now it not only saved, but it also run, but nothing happened. Well, because I wasn't watching the command window. So that was just a focus on that. But of course, you can do it here, and it gave the value, right? In fact, let me do it again. So I'm going to clear this. I'm going to run this, and you see the answer, right? Now, you only see this because everything else was commented out, not commented out, but suppressed. The display was suppressed, right? Okay. Of course, you can do and see every single thing, but then it's going to be painful. But okay, so then you have to kind of scroll up and down, but right. So that's not. And I think you can Control Z to undo things. Okay, so it is a text editor, nothing else. Okay, which is good because you're going to go and take my codes or any codes. So look, I didn't. We were going to talk about this problem, specific problem in class, but if you have no idea what it is, but you want to see what it does, you just copy this text, right? There's no special formatting, just text, right? and you're going to open a new one, paste it here. Yeah, you can save it and then run it. Let's save it pig 1. So we're talking about some pigs here, which is kind of funny, but that's the first example. And then you run it, right? So and in this, there's a bunch of commands that create all these figures, right? Which I just close because it becomes quite cluttered, right? So you don't know what it did. That's why I'm saying, well, you can see some of these numbers, right? But again, it's an ugly thing to scroll up and down, right? So when you're done with a code, again, I haven't showed you how to develop the code, but when you're done with this code, you want to just run it. There are two things to do. One thing is go and do one at a time. See what the code does one at a time. And that's done with this double percentages. So in your code, everything that has this percentage is ignored by MATLAB. So it's just for you to see, right? So with one single percentage, what has two percentages is what's called a cell. So I don't know if you can see, but it gives a different color. If you're in this cell is from here to here, right? And you can run it one at a time. And that's done up here, if you can see my cursor. So you can run the cell and stay in that cell. So let me clear this so you can see. So if I run this, the first cell, well, it did it, but of course there's nothing to display. It just defined that variable, right? Therefore, I should go either to the next cell or just this is more useful, of course. So now I'm in the next cell. Well, take a look at this. I have this new function, which is a function of x. And now I can just evaluate this. And what's going to happen? It's going to plot something, which I don't see. Why I don't see? Because it's no, but it's hidden here. Actually, you know what? Semicolon for plotting doesn't have any effect.
Oh, okay.
Yeah, but it was somewhere in a figure in a place where I couldn't see it, right? But it did something, right? So this is the function that you have to maximize, right? Forget what it comes. It comes from a maximization problem of profit. But now I can go forward and see, well, the next thing is find the maximum, find the derivative, but don't show me the derivative, right? Of course you can see it, but it will be ugly. The next thing is solve the derivative equal to 0. And you see I doubled. Immediately I want to get it in the numeric format. Compute the maximum, x max was found that I showed. And now you can see what happens. I'm sorry if this is too small, but it found the maximum. It even plotted. It's kind of nice visually. Okay, and then it goes into other things, which we'll have to talk about theoretically. Okay? All right? And last thing is, when you're done with this code, what do you do with it? Okay? You cannot. So this is one way to kind of see what it does step by step. Of course, it's also useful for debugging. Like if something's not right, you can go in that cell and modify what you need. When everything's working nice and fine, you can publish this. So this is another feature which is very useful. It just gives you a report of everything. And first it goes through the computation. And you have an HTML file which is already on your computer that is nicely organized. Of course, the formatting, we should worry about this later. The important thing is there is text which is comments, there is commands, which are MATLAB commands, and there is output, which is graphs and values. Okay? So you don't have to look and scroll up and down and look in different, okay? This thing you print and give it to me, but of course, okay? So Monday we're going to talk about how we start, with simple models and get to a code like this and then interpret. Thank you.